Welcome to Reality Creative Video. I'm Hermes, and today we're going to talk about water, the most basic part of any laboratory or chemistry project or anything like that, especially with colloidals. As I've mentioned in previous videos, you need distilled water for your colloidals. The particles that are in tap water just are not going to work because they will interfere with the colloidal process, the process of the metals going into the liquid. So, but there's also another kind of water. There are three kinds of water, okay? I got distilled water in this beaker. I got RO water in this beaker. Now, RO stands for Reverse Osmosis. Talk about that in a second. And tap water in the plastic beaker. Now, each of these have different parts per million as far as dissolved solids that might be in there. You will need a total dissolved solid meter, parts per million meter, to tell you what that is. So I got one here. So if we're going to start off at 0 parts per million, right? We're going to go into the distilled water, and I'm going to place it in here and let it sit for a few seconds. And as you can see, it's 0 parts per million. That's good distilled water. Should always be 0 parts per million. Should be nothing in it. RO water is a process that goes through filters. And there's a carbon filter, there's a regular fiber filter, and then finally there is what they call the RO filter, which is a film filter, where they force, with pressure, they force only the purest of the water through this filter, through this pressure filter. And what can't fit through the pressure filter gets rejected and goes down the drain. That's called reverse osmosis water. We're going to do that one next. Okay, this one reads 8 parts per million. As you can see, the RO water is not completely empty of stuff. Now, the last thing is our tap water. Well, let's test our tap water and see what's in that sucker, huh? Tap water has got so many things in it, 90 parts per million of stuff in there, that the meter turned red to tell me that it's probably not exactly great. In Florida here, tap water is absolutely awful, so it's normal to get a reading of 90 parts per million high reading. So like I said, I have an extra filtration system for drinking, just for drinking water. Now, you can't drink RO water, and you can't drink distilled water. Why? Well, you have to have a certain amount of nutrients in the water, otherwise the water becomes a leach and leaches nutrients out of whatever it is you're putting in, which for our water, it's very, very good. That's what we want in the lab. So what happens if you drink RO water or distilled water? You will actually leach the vitamins and minerals out of your body. And if you're on it it's good for the short term. Like if you had you thought you had some toxic substances in your body, you could drink RO or distilled water for a week, maybe 2, to purge this stuff out of your body. Because what will happen is when you drink this stuff, because there's nothing in the water, it acts like a sponge and it pulls all of this stuff out of your body. It's going to pull the good and the bad stuff out together. But you'll get all the bad stuff out. But if it's on the short term, it's not a problem. Your body will just put those nutrients back. But some people will drink this all the time, RO water and distilled water. And what they're doing is they're removing all of the good bacteria and nutrients from their body, and they're just going to deplete that system. And you're probably going to have to be on vitamins forever and ever because and they won't even stay in the body, because as soon as you take the vitamins, the water in your body is going to absorb it, and you're just going to pee it right out. So you can't drink either of these. You have to have some kind of nutrients in the water when you drink water, so that it doesn't act as a leach. Now, for the lab, RO water I use for cleaning. It's great for cleaning the beakers after I'm done with something, an experiment or cooking colloidals. I will rinse first. First, I'll wash it with Dawn dishwashing detergent. If I really want to get it clean, okay. First, I will use tap water, wash it with Dawn dishwashing detergent, and rinse that all out. And then I will rinse it with RO water to get the last of the suds and the soap from the detergent out of the beaker, and then dry the beaker with a paper towel. And that will clean my beakers pretty much extremely clean, as you can see. Even all my beakers have been cleaned with RO water, and so even doing this distilled water still brings in at 0 parts per million, so it doesn't leave anything behind. If you absolutely want to be sure there's nothing left behind, even after doing the cleaning and the RO water wash, you can spray. I don't have it here, but you can spray your beakers with acetone. Let them sit. Let the acetone go around. You swoosh it around, your beaker. Let it sit in there until it dries out, and there'll be nothing left inside there at all. Then you got 0 stuff in there. So that's my short little chat on distilled water, RO water, and tap water, on the differences between them.